Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi everyone. Today I'm going to talk about stable marriage problem. First, let's define the problem. We have a list of n men and a list of n women. Each man has a preference list over the woman list. For example, man 1 prefers to engage with woman 1. If it's not possible, then engage to woman 4. If it's not possible to woman 2, and it's not possible to woman 3. And the same for all other men group. Likewise, each woman has a preference list over the men list. For example, the woman 1 prefers to be engaged to man 1. It's not possible to man 3. It's not possible to man 4. If it's not possible to man 2. And so on for the other women group. So the goal is to make the marriage possible for both all group members, taking into consideration their preference order. Besides, the result relation should lead to stable marriage. And what do we mean by stable matching? A matching is considered stable if there is no unmatched pair of man and woman who both prefer each other from the current partner. In other words, let's make it simpler. The unstable matching happen if there is a matched pair of man and woman who both prefer each other from the current partner. Like as we see here in the figure below, this man prefers another woman who is engaged to another man. At the same time, this woman prefers this man. So both of them prefer each other over the current partner, and this is considered unstable. To solve this problem, we can use Gale-Shapley algorithm. The steps are as the following. Initially, all the men are free, while there is still a man M who is not engaged. Do the following. So the man M chooses first woman W of his preference list to whom he has not yet proposed. If woman W is free, then we can engage M to W. Else test M prime, who is the current partner of W. If M prime is greater than M, then W will reject the M proposal. Else, we can engage M to W, and M prime becomes free. So let's go through and practice example to understand the algorithm properly. Suppose we have a list of 5 men and a list of 5 women. Each one has his preference list over the other group. So, as we mentioned in the algorithm, first the M1 or man 1 proposes to woman 4. Since woman 4 doesn't have any offer, she accepts the offer from the M1. M2 proposes to woman 5. W5 doesn't have any offer yet, so she accepts the offer from M2. Next, M3 proposes to W2. Since W2 doesn't have any offer yet, she can accept M3 offer. Next, M4 proposes to W5. W5 is engaged to M2, but W5 is already engaged to M2, and M2 is more preferable than M4. M4 will not engage to W5. Next, M4 proposes to W4. W4 is already engaged to M1, and M5 is less preferable than M1, so he will not be engaged to W4. So now we have M4 and M5 are not engaged. In the next round, M4 proposes to W2, but W2 is engaged to M3, and M4 is more preferable than M3. So W2 is engaged to M4, and M3 becomes 3. Next, M5 proposes to W1. Since W1 doesn't receive any offer yet, he can accept the offer from M5. So now the only remaining man who is not engaged is M3. So M3 in the next round proposes to W5. W5 is already engaged to M2, and M2 is more preferable than M3. So they will not be engaged. Next, M3 proposes to W1. W1 is already engaged with M5, and M5 is more preferable than M3. Next, M3 proposes to W4, but W4 is already engaged to M1, and M1 is more preferable than M3. So next, M3 proposes to W3. W3 doesn't receive any offer from any man yet, so he can accept the offer from M3. The result will be M4 is engaged with W4, M2 is engaged with W5, M3 is engaged with W3, M4 is engaged with W2, M5 is engaged with W1. As a discussion question, is this result is optimal for men group or for women group or for both groups? And the second question is, does this result change if we make the women group as the proposing group? Now let's see another application of stable marriage problem. A more general variant of the stable marriage problem is the rural hospital theorem, and the goal is to assign doctors in the position at hospital. The rural hospital theorem differs from the basic stable matching problem in the following points. First, each member might want to be matched to the subset from the other group of the matching. The members of the hospital group might have a limited capacity, so they specify the number of doctors they want to hire. The total number of doctors might not equal to the total capacity offered by the hospital group. The matching results may not involve all members. So here the instability happens when there is unmatched pair prefer each other to their current match status. Therefore, a stable matching still exists and can be found using gate-Shapley algorithm, as we explained. These variant of stable matching problems state that the number of filled positions by doctors in each hospital is the same in all stable matching, and the number of empty positions of any hospital in some stable matching doesn't change in all other stable matching. Thank you.